Hello everyone. So a little update on the automatic half lapping CLT box that I've been working on. As a recap, I've done a first part which was just only one wall, and I've been working on that today, just experimenting a bit more, and I've managed to now add three other walls. So two on the X and two on the Y. And the point of this again was just a bit of an experimentation on the creation of CLT components that already have machining geometry applied to them. So the half lap pre-applied, as we can see over here as well, on all four walls. And I've also now added a lifting hull to each panel, which is controlled by the center of mass or center of gravity, and then using a edge distance attribute to set it from the top. So the tool calculates the center of mass using the density and the geometry of the object, which is in the middle around here on this. This is quite simple. And also numbering. At the moment, the numbering is it's not the best it could be, and I'll have a look to kind of see how to make that better. But it was quite easy to put in, and I thought I'll just include that. So the way that this is controlled through the grasshopper definition is we have the two, as this is just a rectangle or a square, and it sort of scales up and down depending on the attributes. We have panels existing on two different planes, so an X plane, just color coded them for ease of viewing, and on the Y plane, and these are essentially the same walls, although as you can see there's a bit of an overlap that I created just to have a bit of, this is sort of an easier installation rather than sandwiching between two. So we have the thickness, again this is, sorry, the width rather, and this is again based on standard sizes, so this could be any manufacturer standard sizes. It's that sort of component approach to this type of modeling. So if I change this to 5, for example, and make it a bit higher so it doesn't look so weird, this component is going to be 2.5 from the edge of there to the edge of the CLT over there, and the same, that edge there to that edge there. And that's an optimized size, so again that fits within a larger mother panel with little to no wastage. And that's the concept of this. So instead of having a one long wall that you split up and having some remaining portion at the end, this is rather you are adding standard optimized sizes. So you're thinking more about the use of material. So, you know, you can increase that to, we've got 2 there at the moment. Let's just bring this back down to 1 just because it's easier to see everything together. And so, for example, we extend that, and you can see how it just grows there, and that one as well, it's growing there. And nice thing here is everything is, you know, that component-based idea, so it's all the tooling, all the cutting, the machining is sort of already applied. As you can see, the half laps have all added in all along there. You can see it also sort of on here. It adds in there, and it's all adding in, and of course the numbering. So 1 to 6 here, 7 to 12 there, and then 13 to 18 and 19 to 24. And then thicknesses, so this is extruding outward at the moment, sorry, rather inward, which is probably better. But it could be either way, to be honest. And of course it's all adapting to suit, so there's no overlaps, no weird extensions of pieces. The height, which is obviously sort of an obvious value or obvious parameter to add in. And the half lap width. The interesting thing about this here is that you will see as soon as we increase the half lap width, the overall size of this element starts to scale down. And again, that's because you are cutting into the adjacent panels, and you're cutting in and you're cutting in, so you are effectively overlapping the panels by the half lap width, which means that you're creating more material. You would need more material to cover a certain area. So if you think about, let's try something here. So we've got 1, 2, 3, 4, 5, 6 if you see, we're filling up 6 blocks here, and as soon as we start to increase this half lap width, so we still got 6 components, and the components are still all at the same width, 1000, 1000, but we have less space covered now. So you start to see here that we'd have to add another component in here to try to get to a similar overall length. And so that's just the concept about understanding sort of wastage in the half lap. And so, of course, if we bring that back down, it gets bigger. Let's bring it to a more of a standard size, 0.050 millimeters. And let's just make this smaller. Let's go like that. So the new the additional feature that's been added onto here is the lifting hole diameter and the lifting hole distance from top of edge. So I'll show you quickly. There we go. Nice big lifting hole and a distance from the top of edge using the center of gravity. So you can see you can bring that down and up. And again, it's applying to all of those. And so if I change that there and I modify it, it's just adapting and adding more. So that's this feature. That's basically everything that's on this now. Next step is I'll add in some slabs that will automatically adjust according to the correct width. I wonder if they would actually optimize well. By this lapping, I think that they probably wouldn't, but I'll have a look into that. Again, just thinking about the standard sizes. And then from there, probably just start adding stories, perhaps. I'll just give you a quick overview of the script, because maybe that's of interest. So this is the overall, and it's broken into the X and the Y of the wall elements, and shared parameters and attributes, which are feeding into both of them. So it starts with a rectangular outline. Then there's some clusters over here. So if I show you the internal of this one, this cluster is basically creating from the rectangle, it's creating a half lap outline, and that rectangle actually is starting from there. So as you can see, we're pushing into the adjacent wall element and we're cutting over here. Of course, as you'll see, our first walls here don't have lap in there. It's because you wouldn't have it. So the way that I've overcome this is from the rectangle, I array that, so it's still an outline that's getting arrayed depending on the values here. And then from here, I basically look at the data tree and I extracted the first and last elements in the list and modified their shape. So to add the end, to make the end correct. And that's the first and the last one. That's why they work well there. And then, so this little section here is all the outlines along the array. So we've got the middle panels. So if you increase that here, basically 1, 2, 3, 4, 5, 6. So 6 would be the middle panels here. And of course, the outside 2 are over here. And these feed into a little definition over here that's just creating the solid, so it's just extrusion that goes up based on the height value. Then this is the lifting hull. So I use this component called center of mass, and this basically looks at the geometry, so in this case the B-reps, and I've put an internal expression here of nothing actually, 500. Yeah, but in this case it's a rectangular shape, so the center of gravity is pretty obvious. I probably didn't even need to use it. I could have used an area command, but I just wanted to do this kind of in the right way, I think. So this is basically just creating the center of gravity and then adding a cylinder and basically moving it up to the top minus a edge distance value, and that gives us the lifting holes for each panel. And then from this, because all up until this point, this has only been one wall, and then I have just copied this wall over by moving it, and just moved it in 2 different ways. So moved it that way, and then moved it up. And then lastly, just the numbering. So it's just a simple tag. It's sort of one follows the other here. So the first x direction, sorry, is being numbered initially, and then from here I number the y direction, and I just use a list to tell me what the last number is. So we can see here 16, and then I just add 1 so that we can go from 16 plus 1 to 17. I initially did put them all together in one list, but the results were a little more random, and this was just easier to control it. That's basically it. The middle ones is yeah, just a half panel thickness calculation over here that feeds into different attributes in the cluster. But that's basically it. It's not super complicated. I mean, this is not a typical way of designing, so I don't know what real use this would be, but it's a good experimentation to see how these components can be automatically generated, and using the optimized size components as a defining criteria. So a nice way to experiment with stuff. I mean, you could sort of essentially go, let's have these really big, and then okay, you have some window panels, and they fit within the element over here and over here or whatnot. Yep, that's basically it all for now, and I will send some more updates as I get onto them. Great. Well, hope this is insightful for you, and goodbye.